The company announced a new technology claiming it can charge an electric vehicle almost as quickly as it takes to fill a gas car.
In March 2025, under the bright lights of Seoul, BYD didn't just unveil 2 new cars. They pulled the curtain back on technology so efficient, so far ahead, that it's sending ripples through the entire automotive world. Forget the safe expectations of gradual improvement. This was a leap, a 5th-generation hybrid system pairing a 1.5-litre petrol engine with a powerhouse electric motor, anchored by BYD's infamous Blade battery. On paper, the numbers seem unreal. On the road, they are even harder to ignore. And with a range so vast it could take you from New York to Miami and back on a single tank and charge, the question is no longer if BYD will challenge the old guard, but whether anyone can stop them. A launch that shook the room. The March 2025 event was not a flashy marketing spectacle designed to distract from a lack of substance. It was calculated, precise, and dense with technical revelations. The Chin LDMI and the Seoul 6DMI stood on stage looking refined, their designs understated but undeniably modern. Beneath their calm exteriors, though, sat the real story, the DM 5.0 hybrid system. The highlight was not just performance, but range. Over 1,000 kilometers on a single tank and charge. That is territory normally reserved for fantasy, especially in the hybrid segment. Industry veterans in attendance exchanged glances, understanding the scale of what was being claimed. This system was anchored by a petrol engine, delivering either 161 or 215 horsepower, depending on configuration. But the real marvel was how that engine worked in harmony with the electric drive. A thermal efficiency rating of 46.06% may sound like a line buried in a technical manual, yet it represents something historic. No production petrol engine had reached such numbers before. Even Toyota, often considered untouchable in this realm, was left looking over its shoulder. Formula One levels of fuel efficiency had made their way into a consumer vehicle, and not a luxury one either. BYD did not arrive here through luck or sudden inspiration. The years leading to this unveiling were marked by relentless investment. Instead of buying headlines with expensive ad campaigns, they built up a network of 120,000 engineers, scaled manufacturing capacity across continents, and refined individual components until they reached near mechanical perfection. It was a strategy of depth over noise, and in 2025, it paid off. The pricing was the second blow to the industry's expectations. Starting at around $13,000, the Chin LDMI and Seoul 6DMI entered markets where competitors offered far less for far more. While rivals were still debating production costs, BYD was already delivering. When sales figures were revealed, over 4.3 million vehicles moved in the year, the scale of their success became undeniable. This was not a regional win or a short-lived spike. It was an industrial shift in real time, and at the center of it was an engine that rewrote the rules. But how did BYD create an internal combustion engine so efficient it rivaled racing technology? And why has no other automaker been able to match it? The answer lies in engineering choices so precise, they turned convention on its head. The engine that redefined efficiency. To understand the significance of BYD's 5th-generation hybrid engine, you first need to understand just how much energy most petrol engines waste. In a conventional design, more than half the fuel's energy is lost as heat, radiating away through exhaust gases and cooling systems. That inefficiency has been accepted for decades as an unavoidable reality, a kind of mechanical tax paid every time the wheels turn. BYD refused to accept it. At the heart of the DM 5.0 system is a 1.5-litre petrol engine that is deceptively modest on paper. It produces either 161 horsepower for the efficiency-focused version or 215 horsepower for those who want more spirited acceleration. Alone, those numbers might not grab headlines. But when this engine is paired with BYD's powerful electric motor and integrated into their hybrid architecture, something extraordinary happens. The breakthrough is a thermal efficiency of 46.6%, a figure so high it surpasses the long-standing benchmark set by Toyota and edges dangerously close to the best numbers achieved in Formula One racing. Achieving this did not require exotic fuels or experimental prototypes. BYD accomplished it with mass production-ready engineering. That fact alone is enough to unsettle an industry used to gradual improvements measured in fractions of a percent. The key lies in an intricate blend of technologies working in harmony. A compression ratio of 16.1 squeezes every last bit of power from each combustion cycle. Split cooling systems ensure that engine components operate at their ideal temperatures, reducing wasted energy. Precision combustion control allows for microscopic adjustments to fuel-air mixture and ignition timing in real time, and minimal internal friction ensures that the power generated actually reaches the wheels rather than being absorbed by moving parts. In practice, this means that even if the hybrid battery is depleted, the car continues to deliver fuel economy figures north of 80 miles per gallon. For drivers, that translates to fewer stops at the pump and more uninterrupted journeys. For automakers, it represents a wake-up call, proof that the technology to revolutionize efficiency has been sitting in plain sight, just waiting for someone willing to push it far enough. And BYD pushed it with purpose.
This is the BYD stall. This is the BYD Sea Lion 7.
Their engineers didn't chase headline-grabbing acceleration times or record-breaking top speeds. They targeted a balance of performance, economy, and durability that would make sense for millions of drivers, not just a niche few. This meant designing an engine that could thrive in stop-and-go city traffic as easily as it could on long stretches of highway, all while seamlessly integrating with electric drive to minimize petrol use. But this engine is only one part of the story. BYD didn't just build a more efficient heart for their cars, they rethought how the entire hybrid system should behave. In most hybrids, the petrol engine takes the lead role, with the electric motor stepping in occasionally to assist. BYD inverted that relationship, making the electric motor the primary driver and letting the petrol engine act as support, engaging only when needed. This shift in priorities changed everything about how the car feels and how efficiently it operates. The result is a driving experience that feels effortlessly smooth and surprisingly quiet. But that's only the beginning, because while BYD's engine may have rewritten the efficiency playbook, their true ace in the hole is something else entirely, a piece of technology that has already begun to change the way the world thinks about batteries. The Blade Battery Advantage. In the electric vehicle world, the battery is more than just an energy source. It is the foundation on which everything else is built. For years, manufacturers struggled to balance range, cost, safety, and longevity, often excelling in one area while compromising heavily in another. BYD's answer to this problem was not to make incremental tweaks to existing designs, but to create something entirely new, the Blade battery. On the surface, the name might sound like a marketing flourish, but it comes directly from its design. Instead of using bulky, box-shaped cells that leave wasted space between them, BYD developed long, slender cells arranged side by side, resembling a row of blades. This arrangement dramatically reduces dead space inside the battery pack, increasing energy density by as much as 50% without enlarging the pack itself. This structural innovation also turns the battery into part of the vehicle's chassis, enhancing rigidity and stability. A stronger structure means better handling and improved crash safety. Making the Blade battery more than just an energy solution, it becomes an integral part of the car's performance and protection systems. Safety, however, is where the Blade battery truly sets itself apart. Lithium-ion batteries have long been plagued by thermal runaway, a dangerous chain reaction that can cause overheating, fires, or even explosions. In BYD's brutal nail penetration tests, where a metal spike is driven straight into the cell, most batteries react violently.
Today we're going to look at the BYD Shark hybrid battery pack, which is sitting off here to my side.
The Blade battery stays cool, calm, and inert. No fire, no smoke, no chemical venting. This is achieved by using lithium iron phosphate chemistry, which is inherently more stable than the nickel-cobalt-manganese blends favored by many rivals. That stability comes with another major advantage: longevity. After 3,000 full charge cycles, the blade battery still retains 90% of its original capacity. For a typical driver, that means well over a decade of use before any noticeable degradation, reducing both replacement costs and environmental waste. And because lithium iron phosphate is more abundant and less geopolitically fraught than cobalt or nickel, BYD's supply chain is more stable, less ethically problematic, and less vulnerable to price shocks. Charging speed is another arena where the blade battery delivers. Its chemistry and cooling design allow for faster charging without excessive heat buildup, meaning less time tethered to a charging station and more time on the road. For daily life, it also enables a unique kind of hybrid flexibility. With the DM 5.0 system, many short trips, school runs, errands, commutes can be completed entirely on electric power, keeping the petrol engine dormant. That means the blade battery doesn't just store energy efficiently, it actively reshapes driving habits, making the transition to electrification seamless for drivers who have never owned an EV. But perhaps the most significant impact of the blade battery is strategic. By solving safety, efficiency, and longevity in one package, BYD has effectively eliminated some of the biggest excuses consumers and competitors have used to delay widespread EV adoption. In markets where EV infrastructure is still developing, the battery's long life and hybrid integration mean drivers can adopt new technology without fear of range anxiety or premature wear. Yet even with a revolutionary engine and an industry-leading battery, BYD's vision goes further. Because in their eyes, a truly modern vehicle isn't just efficient or safe, it's intelligent. And the way they've taught their cars to think is as disruptive as the way they've taught them to drive. The brain behind the machine, engineering a powerful hybrid system and an industry-leading battery, is only part of the equation. In BYD's eyes, a modern car must be more than a collection of advanced components. It must be a cohesive, intelligent organism capable of thinking, adapting, and protecting its occupants in real time. That is the philosophy behind Schwanji, BYD's centralized vehicle architecture. In traditional cars, the electronic systems that control everything from braking to climate control are scattered across dozens of independent modules. Each one has its own processor, software, and wiring, which means communication between systems can be slow and prone to inefficiencies. Schwanji eliminates that fragmentation by consolidating control into a single, high-speed core. This unified brain connects the engine, electric motor, sensors, cameras, brakes, and safety systems into one constantly communicating network. The advantage of this approach is measured in microseconds. When a driver brakes suddenly to avoid a hazard, Schwanji can instantly coordinate power delivery, ABS, and stability control without waiting for multiple systems to exchange data. The same responsiveness applies to steering adjustments, throttle modulation, and even adaptive suspension tuning. In practical terms, it's the difference between narrowly avoiding an accident and being unable to react in time. But Schwanji's intelligence isn't static. Powered by BYD's DeepSeek AI, it learns from every journey. The system constantly collects data from the car's sensors and adjusts how it manages energy use, braking force, and even component maintenance schedules. If a particular driver tends to accelerate aggressively in city traffic, Schwanji will adapt its power delivery to preserve efficiency without dulling performance. If road conditions in a region are consistently poor, it can optimize suspension and traction control to suit. This adaptability is amplified by BYD's vast network of connected vehicles. With millions of BYD cars on the road sending anonymized data back to the company, the AI is trained and refined at a pace that rivals cannot match. A rainy day in one city teaches lessons that are instantly applied to vehicles on the other side of the globe. Pothole detection in a rural province can improve ride quality in a distant urban market by the end of the week. Over-the-air updates ensure that Schwanji never stops evolving. Much like a smartphone that gains new features and security improvements over time, BYD vehicles can receive performance boosts, enhanced safety algorithms, or entirely new driver assistance capabilities without ever visiting a service center. This not only future-proofs the car, it builds a level of trust between driver and manufacturer that is rare in the automotive world. Yet, Schwanji isn't about tech for tech's sake. Its purpose is deeply practical to make driving safer, smoother, and more efficient. In an industry where many manufacturers still treat digital architecture as an afterthought, BYD has made it the foundation of their vehicles. It is the invisible partner that manages every aspect of the drive without drawing attention to itself, letting the driver simply enjoy the journey. And while Schwanji represents the car's mind, BYD's ambitions don't stop there, because the next step in their vision is to give that mind the ability to act on its own, ushering in a new era of practical, accessible autonomy, driving into autonomy with DePilot. While many automakers speak about self-driving as a distant milestone, BYD treats it as an active project already in motion. Their DePilot system is not a prototype locked away in a research facility. It is a fully functional suite of autonomous and semi-autonomous capabilities already deployed across multiple production models. At the heart of DePilot is the DeepSeek R1 neural network, a machine learning system trained to interpret the chaos of real-world driving. Unlike rule-based driver assistance programs that follow rigid instructions, DeepSeek R1 is designed to think more like a human. It can weigh multiple variables simultaneously: weather, traffic flow, road surface, and driver behavior, before deciding how to act in a fraction of a second. The system is tiered to match different vehicle segments and customer needs. DePilot 100, aimed at entry-level cars, offers adaptive cruise control, lane keeping, and automated emergency braking. DePilot 300 expands capabilities to include advanced navigation-based autopilot, intelligent lane changes, and self-parking functions. At the top sits DePilot 600, which delivers high-speed navigation on autopilot, hands-free driving on mapped highways for hundreds of miles, and memory-based parking that can return the car to a stored location without driver input. What makes BYD's approach unique is that these features are not reserved for luxury buyers. Even budget-friendly models under $10,000 can access some level of DePilot functionality, democratizing technology that other automakers charge a premium for. The development process behind this system has been relentless. BYD employs more than 5,000 engineers dedicated to refining DePilot's performance. Each day, the company's global fleet generates 45 million miles of driving data. Every unexpected pedestrian crossing, sudden lane closure, or unusual weather pattern encountered by one vehicle becomes a learning opportunity for the entire network. This constant feedback loop allows DePilot to improve at a rate traditional software cannot match. The more BYD cars are sold, the faster the system evolves, creating a competitive advantage that grows with each passing year. The eye doesn't just react faster, it anticipates. If traffic patterns indicate a potential hazard ahead, DePilot will adjust speed and positioning before the driver even realizes a risk is present. Safety remains the system's priority. In heavy rain, when cameras might struggle, DePilot shifts reliance to radar and ultrasonic sensors. In bright glare, it uses shadow mapping and infrared assistance to maintain accuracy. The transition between these sensor modes is seamless, ensuring no lapse in coverage or control. In practice, DePilot is not about replacing the driver entirely, but about eliminating the most dangerous aspects of driving: fatigue, distraction, and delayed reaction times. By reducing the mental strain of long journeys and assisting in complex traffic situations, it allows drivers to remain alert and confident. The beauty of BYD's system is that it integrates so naturally with the Schwanji architecture. The same unified brain that manages the vehicle's performance is also orchestrating autonomous functions, meaning no lag between decision-making and execution. This tight integration ensures that when the car decides to act, it acts instantly. And yet, for all of BYD's breakthroughs in engineering, intelligence, and automation, there is one more piece of the puzzle: the ability to make all of this accessible without pushing prices out of reach. That is where the company's most disruptive advantage truly lies. Affordability without compromise. For all the technology and engineering brilliance behind BYD's fifth-generation hybrid system, none of it would matter if it were priced beyond the reach of the average driver. This is where BYD's strategy becomes truly disruptive. Instead of using innovation to justify luxury price tags, BYD has turned advanced technology into a mass-market offering. Their vehicles often come in 15% cheaper than comparable models from competitors like Tesla, while offering features that rival or exceed luxury brand standards. Even their budget models, some priced under $10,000, include hybrid drivetrains, advanced driver assistance, and the durability of the Blade battery. It is a combination that forces buyers to question why they would pay more for less elsewhere. This accessibility is not accidental. BYD's vertical integration allows them to produce batteries, motors, and control systems in-house, cutting costs without sacrificing quality. Government subsidies in China have further allowed them to scale production rapidly, making it almost impossible for rivals to compete purely on price without slashing their own margins. However, this aggressive affordability has drawn political pushback. Heavy tariffs in the United States and new import duties in the European Union threaten to slow BYD's expansion in key Western markets. Yet, even with these barriers, BYD's dominance in Asia and emerging markets ensures their momentum continues. BYD is not simply selling cars. They are selling the idea that the future of mobility should not be limited to those with deep pockets. BYD's fifth-generation hybrid technology is more than just another step forward in the automotive industry. It is a reshaping of the rules. With unmatched efficiency, intelligent architecture, practical autonomy, and disruptive pricing, BYD has proven that world-class engineering can be both innovative and affordable. If this is what they can achieve in 2025, imagine what the next 5 years might hold. Could they become the dominant force in global mobility? Tell us your thoughts below. And if you enjoyed this deep dive into industry-shaking technology, hit like, subscribe, and turn on notifications so you never miss what's coming next.